for opening or writing the equation in point slope form. Now, remember, the point that you choose to put in the equation, it doesn't matter. Even if you choose the y-intercept and you write it in point slope form, that's okay. Okay? But I do want it to be in point slope form because that's going to be a little bit more applicable for what we might do when we go to write it from a table. And that's our lesson for today, writing the equation from tables and or points. So at the very minimum, everybody should be able to find slope. Okay? I know that it is a positive slope line because it's going up as I go to the right. Rise over run. My run is 1. And then the rise is 1, 2, 3. So that makes our slope, rise over run, 3 over 1, which is just 3. Then after that, it just depends on which point you choose to put in your equation. And again, it doesn't matter. Okay, let's say I choose point D. Point D has coordinates that are 1, 5. So this is my x1, y1, and I can highlight those in the actual equation. So now it's just piecing everything together. So starting with y minus the y coordinate of 5, and it equals the slope of 3 times x minus the x coordinate that we chose being 1. Okay, so that's one correct equation. Now again, you might have something different, and that is okay. It all depends on the point that you chose. So how does this process change when we're working in a table? Really, the only thing that changes is how we find the slope, right? Because now I'm not trying to find the rise. Well, I'm kind of finding the rise, right? Another way to think about rise is change in y, right? So when I'm finding my rise in the table, really I'm identifying the change in y. When I'm finding the run, I'm finding the change in x. Okay, so nothing really changes. We're just combining how we find slope and then putting together an equation. Okay, so let's just use these first 2 points. This value that I'm about to find is my change in y. And to go from -4 to -1, I'm having to add 3. -2 to -1, I'm adding 1, and that's the change in x. So that change in y divided by change in x equals our slope of m, which is 3 divided by 1, which is 3. And then after that, we just pick any point in that table and use the x and y coordinate in our equation, just like we did from the graph. Let's just pick the same one, this 1, 5, and I'm going to piece it together and get the same equation. So y minus the y coordinate that I chose, which was 5, and it equals 3 times x minus 1. That 1 being the x coordinate from the point that we selected. Okay, so again, doesn't matter what point you choose. You can find slope and use any point in that equation. All right. Writing equations of lines from tables and points. Again, nothing changes. That's the kind of main talking point here. So we still need the slope and a point on the line. And we're going to actually work on getting equations in both forms, point slope and slope intercept. Okay. All right, go and flip this page over. And there will be a lot of, maybe even today. Oh, I know what we're going to do. I'm going to go through some of the examples, and I'll have you all do some as well. But we're going to have you guys earn the homework today. Remember we used to do that first semester, where you've got to show me the work to be able to get the homework. So we're going to do that today. Hopefully that gets some better attention, because there's still some of you making faces at each other while I'm talking and not listening at all. So hopefully that helps. Okay. I'll do number 1. I'll have you do number 2. We'll probably skip some of these because we don't need to do all of them. So again, let's just start by finding slope. To find slope, I'm just finding any change in y and any change in x. This change in y right here is plus 2. This change in x, -7, -4, is plus 3. Making my slope 2/3. And then just for while we're going through these notes today, especially when you're working on problems in your groups, let's just always select the bottom point. Okay, that way the equation you write is going to be the same as what I write. But again, it doesn't really matter. So the point I'm going to choose to use is 5, 8. So that makes us y minus 8 equals 2/3 times x minus 5. Okay, why don't we skip number 4? I want you all to do 2 and 3 right now on your own or in your groups. We'll give you like 4 minutes, 2 minutes each. We'll go over those. And we've just got a couple more things to do here. All right, you're all set. 2 minutes. 4 minutes, sorry. Again, if you chose the bottom point of the table, then all your equations should match what I have up here exactly. Starting with the slope, going from -6 to -5, I'm adding 1. -8 to -3, I'm adding 5. So my slope, rise over run, or change in y divided by change in x here is 1/5. And the point, I chose to use 12, -2. Making my equation y plus 2, where that y coordinate, the sign is opposite, equals the slope of 1/5 times x minus 12. 12 has an opposite sign as well. And the last one, again, basically the same thing there. I wouldn't count it wrong if you left your slope as -8/2. I'd prefer that we reduce those down and say that that's -4. But if you write -8/2, I'd accept that as correct. Okay, I'll go with me still. And then going to the equation, -23 is the y coordinate, so it's y plus 23 in the equation, and then x minus 4 in the equation as well. Okay, pretty straightforward so far? Hopefully we're feeling that way. Okay. This is also reviewing some of the lessons we had with slope. In fact, we're going to continue with that as we talk about how does this change if we have 2 points? Well, right off the bat, it doesn't need to change, right? It's the exact same. One thing that I had us do when we are given 2 points is we make a table. So 4, 7, -2, 5. And it's the exact same problem as what I did before. So finding change in y, -2, and change in x, -6. From the slope here. What's that? It does not matter at all. Okay, so Henry's asking, does it matter if we reverse and put these points, the other one up top, the other one on bottom? Doesn't change one bit. Because now my change in y is +2, so it changes that sign, but it's also going to change the sign on the change in x as I'm adding 6. So my change in y divided by change in x is either -2 divided by -6 or +2 divided by +6. So I'm actually glad this got brought up. Is the slope positive or negative? I'm hearing lots of different answers. I'm seeing everything positive here, but what's a negative divided by a negative? A positive. So if I have a negative change in y and a negative change in x, those negative divided by negative still makes us positive. So that's still 2/6. Okay, so no matter what, your slope here is positive. And then the point used in the equation, it doesn't matter. So it's y minus 7 equals our slope of 2/6 times x minus 4. Yeah, I'll just wait. Okay. I'm going to ask, so you do 5 and 6, and let's just do it the same way. Okay, find slope the same way that I just did. Write the equation. I don't care which point you choose in your equation. I'll do the same thing. And we've got one more page that we're going to work through. That second page is how we're going to earn homework. I'm going to have you wait because on this last page, yeah, just wait because I'm going to be doing something a little bit different with these ones because we're going to write in slope-intercept form. So just hang tight for just a little bit, okay? I think a lot of us are getting the hang of this and have already kind of moved ahead, which is okay. But let's make sure we have these 5 and 6 down. So regardless of where you're at, flip back to problems 5 and 6. For 5, your slope ends up being negative 3/2. You get a positive divided by negative, and if you flip which point's on top and which one's on bottom, still end up with that same thing. The point I chose to use in my equation this time was negative 3/7. If you want to use the one that I listed in the bottom, negative 5/10, that's absolutely okay. It does not make a difference. Again, there's a lot of right answers for how we can write an equation. Okay, I'm plugging everything in. Based on the point I chose is y minus 7, and it equals negative 3/2 times x plus 3. All right, for number 6, I find my slope to be negative 8, or the change in y to be negative 8, the change in x to be positive 6. And I've mentioned this before, especially when we were graphing, and we had slope where the rise over 1 was fairly big numbers like this, where we can reduce down the slope. Now, it's not something I'm going to make us do, but for those of you that kind of know that you want to continue and push yourself in math, reducing fractions shows up in every single math class you'll take from here on out. And every time you do math, it happens all the time. So the reducing of fractions has us looking at the numerator and denominator and dividing any numbers or dividing out any numbers that they have in common. 8 and 6 are both divisible by 2. So if I divide both of those numbers by 2, that gets me my slope to be negative 4/3. Okay, that is what's called the reduced fraction of negative 8/6. You don't need to do that, okay, but for those of you that are picking up on that, I would absolutely do that every time, okay, because it's something that you actually end up doing quite a bit of when you get to like Algebra 2 and pre-calculus. All right, then I chose 5 comma negative 9 to use in my equation, making it y plus 9 equals negative 8/6 times x minus 5. Okay, the next page, we've got a couple different things that are going on there, so I do want to go over these two things here. And then also how we write the equations, because some unique things happen here. So right off the bat, I look at this problem. I see that I've got 2 points. When I have 2 points, I need to find the slope. So I'm going to make a table. So x, y. So negative 5, 7, negative 5, 10. And I go to find my change in y and change in x. So 7 to 10, I add 3. Negative 5 to negative 5. There's no change. That change is 0. So when I change when I do y divided by x here, or change in y divided by change in x, I get 3 divided by 0, which is undefined. Now that right there should signal something, right? Because we don't get slopes that are undefined or 0 all that often. And this is where you kind of have to make the connection. Well, what does this look like? If I get an undefined slope, what slope lines are undefined? Okay, those are the ones that are vertical, right? Ones that we can't walk up. So this is a vertical line, and that undefined slope is kind of the signal to that. So then the way that I write equations of vertical lines, it's not point slope form. I'm not going to say y minus 7 equals undefined times x plus 5. We have to think about what is staying the same here. And with the points, it's actually pretty straightforward, right? It's this x coordinate of negative 5 that stays the same for every point that's going to be on this line, making our equation x equals -5. Okay, so point, there really isn't one. And the slope is undefined. All right, now the same is true for number 8. Here, not exactly the same, but when I go and find the slope here, so -1, -9, 5, -9, my change in y is adding 0. My change in x is adding 6. So now, when I take change in y divided by change in x, I get 0 divided by 6, which is 0. So one thing I did see on somebody's work here is they're like, oh, I've got a slope, I've got a point, so 0, -1, -9, and thus I can write the equation of that line as y plus 9 equals 0, x plus 1. We weren't really able to do that with the undefined slope there. So this is mostly correct. Okay? If you did write this on a quiz or a test, I'd give you most of the points. But with vertical and horizontal lines, we need to write them in that correct form. So what happens here, I recognize that if I distribute the 0, what's 0 times anything? 0. So all that goes away and I get y plus 9 equals 0. And then when I subtract 9, I get y equals -9. So even if I started with that equation in point slope form, I can get it in its right form where y is just simply -9. And that's also what is staying the same. Okay. Any questions with the horizontal and vertical lines there? Okay. For the next ones, this is how we're going to earn our homework. I'm going to do number 9. You all need to do number 10, and you need to show it to me to get your homework. And we're going to add one extra piece onto what we need to do with these. Because it's write the equation of a line that goes through the two given points in slope-intercept form. So we're going to have to do something to that equation. Well, I'm going to start out the exact same. I know that I can take 2 points, I can find the slope and write it in point slope form. So I'm going to find my slope. I'm going to look for change in y, change in x, and that gives me my slope as 1/2. And I'm going to start off with any point again, just like what we've been doing. So let's use the 6, 7. Plus 2. 2 divided by 2 is 1. Good catch. And so I'm going to write this equation in point slope form by saying y minus 7 equals the slope of 1 times x minus 6. And what we're going to do to get it in the slope-intercept form, we're going to convert it. I did this yesterday. And the way that we convert it is we basically work to get y by itself, starting with distributing the slope. Well, distributing the 1 times both those terms just makes them the same. So it's just x minus 6. Then, to get y by itself, I need to add 7 to both sides. And so I get y equals x plus 1. And now that is in slope-intercept form. I'm sorry, you can't see that. There we go. All right, so for you to get your homework, I need to see the work for your equation in point slope form and then convert it into slope-intercept form. If I don't see your work and you don't get a homework today, that means we are not on task because you have almost 20 minutes to do one problem. And if you don't get the homework today, that's on you, okay, for not being productive. So you get, really this should take you like 2 minutes, but you got till the end of class to get this problem right. Show it to me if it's not right. I'll help you. I'll show you what's wrong, and then you'll fix it. All right, you're all set.